everybody. Good afternoon. How are we feeling? We're awake and we've had some cake, so we're all good? That's what I like to hear. Hi, everybody. It's so great to see you all, and it's nice to be in Manchester. So my name is Carly, and today I want to talk about observing AI applications, as you can see right above my head. I'm going to focus specifically on OpenLit and OpenTelemetry for the actual kind of code portion, but what I'm hoping is you'll take away relevant principles of what kind of things you're looking at when you want to observe LLM applications. And I'll also point out any relevant kind of alternative technologies along the way. But if I cover something you're not sure of, we should have time for questions at the end, and I'm happy to answer them. So if we dive in specifically, I'm going to cover traditional instrumentation with OpenTelemetry. So I guess a show of hands, who's heard of OpenTelemetry before? Okay, so for you, this might be a bit of a refresher. But by the end, everybody will understand what we're talking about. We'll talk about why AI systems are different and why we actually need kind of additional capabilities in our arsenal. And then we'll talk about how we can use OpenLit on top of OpenTelemetry for that additional tracing capabilities. And then at the end, we'll also talk about evaluations and guardrails and why these are an important aspect for observability as well. So if you haven't met me before, well, I've been mulling about here. Hi, it's really nice to meet you. My name is Carly Richmond. I lead the developer advocacy team, which is part of DevRel at Elastic. Been there for 3 years. And before that, I used to work at Morgan Stanley for 10 years as a software engineer. So yeah. By the way, we don't get time for questions, but we should do with my timings if it's all going to plan, and the demo gods are nice to me, so demo gods, please be nice to me. We should have time for questions, but if not, I collect socials like Pokemon these days, so just find me whatever works for you if you want to reach out. So hopefully we all know what observability is, right? We're comfortable in this definition. This is not surprising me what's above my head right now. Cool. So yeah, it's the idea that we need to collect information about what our programs are doing, from the internal states of given components to the communication between them. And for me, coming from the background I did, this was particularly important because while I was a front-end engineer, a lot of the time it wasn't my fault that something was broken. Sometimes it was, I'll hold my hands up. But sometimes it can be down to a particular microservice, it could be issues with a database or another layer. And when we have these complex systems with loads of interconnected components, irrespective of whether they have AI in them or not, we need to be able to see what's going on within them. So, just a reminder, OpenTelemetry, CNCF incubation stage project, formed in 2019 through the merging of competing standards. So we said we had some OTel aficionados in the audience. Can people remember the name of the two standards that merged together? No? So it was open tracing and open census. Is that familiar? That's fine. It was a long time ago. And the thing that I like about OpenTelemetry is it's vendor agnostic. So it gives us capabilities such as the protocol, OpenTelemetry protocol, commonly shorthanded to OTLP. It gives us different SDKs, which is useful if you're working across multiple languages like I've done in the past. And it gives us tools for us to basically be able to observe our applications, generate the telemetry we need, and then send them to whichever OpenTelemetry compatible backend, of which it's emerging that the majority are. And this is important because I talked about that kind of microservice and front-end experience I talked about before. And one of the things I always found really weird is the fact that we were using different tools to cover different aspects of the layer. Quite often they had different contracts and different ways of talking. And while some aspects might be particularly specific, so we think about front end, you'd look at, metrics are very specific to front end, like core web vitals, compared to back end, where we'd maybe look at more of kind of CPU and memory. The fact still stands that we should be able to at least understand, using equivalent specifications, what the data looks like, because that makes our job easier to understand. So, example of automatic instrumentation, most of us in the room already know this, but this is the idea, or basically where we can have a process. OpenTelemetry self-attaches onto that relevant process without the need to change code, and that allows us to basically get some basic out-of-the-box configuration before we start adding in our own custom tracing within the code itself. Certainly, I found this advantageous for maybe those older components that you're too scared to touch. Has anyone got any of those sitting in their stack at the moment? Yes! See? I'm not the only one. So the way that we tend to do this, as you'll see in the above example, is this is the .NET example. So you basically download the relevant script to set it up and then store the core dependencies. We then enable the instrumentation and set it up. And then from there, we specify the relevant environment variables, which covers things such as custom attributes you want to apply to our particular signals. I've got version and environment here because I normally had to compare to prod and non-prod and what we deployed this week versus last week to see what had broken. A unique name for the service, which I think is obvious, so we would call that the resource name in OpenTelemetry terms. And then, of course, where we're going to send it to is the endpoint, passing in the appropriate credentials via the header. And then here I've specified the exporter format as OTLP, so I'm sending to an OpenTelemetry compatible backend, so everything should hopefully work. And then obviously when I start my app, hopefully it should self-attach and everything should be happy. Does that all make sense? Cool. Now, if we do this manually, and this is where we do a bit of a hop, so does anyone do any TypeScript development at all? A few? Okay, cool. So this is actually front-end instrumentation example, which is a bit quirky and a bit different. So what you'll see is I'm setting up the resource here. It's slightly different because I've got a browser detector. Now, this allows us to pull in the relevant environment attributes associated with the browser. So that would be things such as the brand, is it running on mobile versus desktop, and all those other kind of useful user agent information, which will then attach on as attributes so we can see what's going on. So like if you've ever had the situation that I've had, where I've had users trying to use Internet Explorer and everything magically breaks, you'll be able to detect that through the brand attributes. Does anyone still have to support Internet Explorer, out of curiosity? I'm so sorry. I've been there. I feel your pain. But in addition to the detection from that, we may want to specify our own custom attributes, which is what I've done above with resource from attributes, specifying a service name and those optional attributes that we did similar to the .NET example, and then basically merging them together using merge, which should hopefully make a lot of sense. Now, it doesn't matter whether we're still talking about AI systems. There are three main types of signal that we're going to want to capture. Some aspects may be different, such as the types of metrics we're going to capture, or indeed sometimes some of the tracing and the way we look at it and what kind of insights and particular spans are going to be in those examples. But we're still going to capture three main types of signals. So the first one is logs. We all know what logs are, don't we? It's these structured error messages that are normally spit out to a file and then forwarded on to an elk stack somewhere. Or in your case of anyone working on front end that are basically spat out to the DevTools console and we never worry about it. Yeah, those ones. So the way that we configure the logging on the front end is actually we specify an exporter first. So I've specified an exporter here. It's utilizing the OpenTelemetry protocol because I'm sending to an OpenTelemetry protocol compatible backend. We specify the URL where we're sending it to. And then utilizing that exporter, we then create a provider, connecting that resource to that particular exporter via a processor. And here I'm sending as via batch log processor to send logs in batches, which for production systems seems to make sense. You don't want to flood it with all the messages, especially if you've had situations like myself where your kind of elk infrastructure is like a centralized service used by multiple development teams who send anything out, including whatever garbage. So we need to think about that as well. And then from there, in our code, we set the global logging provider. And then instead of console.log, for anyone doing the front-end stuff, we change it to logger.emit, which is similar to what you might think of with .NET and other ecosystems where we invoke a logger and send out the appropriate messages. And then as if by magic, we end up with telemetry signals inside of a stack that we can then perform searches on. We can get useful metrics and count statistics, and we can try and understand what's going on. Make sense? Now, obviously, if we're thinking about AI systems, this is still relevant because these components are still going to have logging messages littered throughout them. Furthermore, if we're building chatbots and front ends, there's still going to be particular interactions that we want to pick up and be notified about. So it's still relevant in the AI age to still lean on to those fundamentals. Now, the next thing we have is metrics. Now, I'm aware this is a Java example at a primarily .NET conference, but the principles are still the same. For a backend, the types of metrics we tend to want to capture would be CPU, memory, the state of the heap, my garbage collection, kind of spaces and information, all thread counts, all these other kind of useful things to try and basically establish the trending over time in my service, see if it's perhaps getting towards particular thresholds, and then start to say, oh, maybe I need to do something because the service is about to fall over. But when it comes to front end, we also have Core Web Vitals to capture, and these are a set of measures that allow us to evaluate the user experience. So who's heard of Core Web Vitals? One person. No, two. Okay. So I recommend a resource. It's basically web.dev, gives a great overview and actually goes into the details of the particular instruments. But the reason why these are important is they cover the human factor of basically observing they're not a silver bullet, no metric is. But what you can see from these is things like, is the site taking considerable time to load, probably annoying my user, meaning they're going to go somewhere else? Is it reacting promptly to inputs, as you think of with interaction to next paint? Is it, giving them tons of ads? Are they having to scroll all over the place to try and find the information? And if we're utilizing style chatbots or embedded AI systems that are perhaps making decisions about maybe financial aspects or trying to approve them for a loan, which is probably where we're going to end up, we still need to be able to capture what the user is doing alongside what the AI is doing as well. So here's an example of a custom instrumentation I've written that you can use utilizing the Web Vitals JavaScript library in order to pull in the relevant metrics. So the way that metrics work is that firstly we need to create a reader which is going to read the associated measures. Obviously with automatic instrumentation, particularly if you enable kind of sensible defaults of instrumentation types, it's going to figure those metrics out for you. But here we're doing something custom. So you've got a reader that's periodically going to capture these values for you. Now I've set it with an export interval of 10 seconds for demo purposes. I don't recommend 10 seconds for a production system unless you want to overload your backend again. But we basically can specify how often we're going to read these particular values and then utilize the exporter to say where we're going to send them to. So a very similar pattern of exporters starting to emerge. We then return our provider, which connects, again, the resource and the reader this time. And then what we do is set that as our global provider. Very similar to what we did with logging, isn't it? And then from there, we get a hold of the meter. And then within a meter can comprise of multiple instruments. So I've got basically an observable gauge for each vital that I want to capture from the library. I've created observable ones similar to how the fuel gauge would work on your car. And that should do everything I need. So when I go to enable, so this is the callbacks for Web Vitals. So when these particular vitals are captured by the Web Vital library, it's going to send the metric via a callback function that I have defined down here. And what that does is specify all of the attributes that I want to pull in from the Web Vital metric that's been captured, and then to send it its result.observe. And when we do that, this is basically what we end up seeing. So you can see all the way up at the top, I've got the relevant entries that are passed in. So everything I added is sitting in the attributes. And then we can do funky things like dashboards. We all love a good dashboard, don't we? Especially when there's no red in it, like this one, which is nice and happy. So then the last thing is traces. So who knows what traces are? Not all of us. So what traces are is a way of showing pathway of execution through all of the services and layers within an application. So going back again to that kind of services-based approach that I talked about, I often needed to kind of follow through, kind of following the trail of thread all the way through the system to try and figure out which particular component was broken or misbehaving. So this allows us to see that because through correlation, we can see what the operations are for each individual component that's been instrumented with OpenTelemetry. And we can see how long each of those respective actions are. And the way that that works is because a trace comprises of multiple spans, which are the smaller elements underneath, that form a parent-child relationship so that you can see the correlation of who called what. So this is a really simple example that I have above, where it's a simple web service that's basically calling a Java backend service. Nothing too complicated. We'll see some crazier ones later. But the way to pull this in is generally creating an exporter similar to what we've done for logs and for metrics. We create a web trace provider, because this is web signals that we're capturing here. and we specify the resource, and then using our exporter, a batch span processor, to send things in batches again. And then we register the provider. Now, the bit that gets different here is you'll see I've got a context manager and a set of propagators. The reason for that is that within OpenTelemetry, like us humans, they all have baggage in terms of their transactions, but they also have context too. So what context is, when we think about tracing, is basically the attributes that can be used for that correlation. So remember I saw above that there was 2 different services. They need to know kind of what invoked each other. An active span ID is the primary attribute in context that allows us to see that. Baggage is user-defined values that you would want to add on to the top. But the kind of idea is that you've got these attributes that add on to your spans as supplemental information that can help us figure out what's going on. So, of course, we can capture traces for all sorts of different types of events in a system. And the way that we do that is by registering instrumentations. So here above, I have several different instrumentations. So I've got one to capture document loading times. I've got one for capturing fetch and HTTP requests. And I've also got user interaction as well, which is going to capture click and input events, which are still important. I know it might feel a bit creepy to be the fact of, oh, this user is clicking this button at this particular time on a Tuesday. But actually, when you've got a flow of triggering associated services, requests, and things off the back of user interaction, sometimes one of the appropriate things is to see where it starts when you're trying to establish a timeline in an outage situation. So it's actually an important piece of information to gather. Also, if you're seeing loads and loads of clicks, it might be, and then maybe double responses off of them, you can start to see things like, oh, maybe the service is being invoked twice for some reason, which I have had happen before. So that's how we end up with these traces that I've talked about. And of course, as I said before, you can see here, we've got this notion of a span ID and this parent-child relationship within them, which is how the systems are all going to correlate them together. But you're here today to hear about AI. And you're probably wondering, well, why is AI different? You know, why can't I just use OpenTelemetry? Well, there's a few different reasons as to what makes AI systems challenging to observe and also to diagnose issues for. Firstly, these models are probabilistic. You know, the way that they work is that they're basically through a set of probabilities figuring out what the next word in the sequence is. That therefore means excluding even aspects of temperature, which for anyone who's not familiar is a parameter that we can kind of tweak and specify in models to determine how deterministic or chance-based they are. With that, what we tend to find is even considering temperature, they might end up generating the different results depending on other factors. It can depend on how the context has evolved over time as it's generating particular memory messages. It isn't necessarily going to behave the same way every time like a single-threaded kind of procedural application would have done historically. Second reason is we don't actually have a lot of insight into these components because they're black boxes. So they're making a lot of decisions that we don't necessarily have much tracing in. But they can also perform actions. So if, like we've seen with some of the other talks, you have a particular agent that's invoking multiple tools, how do we know that it's going to get to the right answer? How do we know that it's calling the right tools? And also, how do we know that it's calling it the right number of times and it's not littering through burning tons of tokens because it's calling the same tool 4 times and expecting a different result? There's other aspects as well, like given if we are making these publicly available and exposed, we therefore have aspects such as reputational and regulatory risk to consider. You know, we've all seen numerous different stories, and numerous talks at this conference have also shown headlines of examples. We've seen all these examples where, due to issues, due to people managing to manipulate the bot to do something or to say something, it's ended up saying something ridiculous or something offensive or something toxic. And we need to know about that for reputational reasons and be able to be alerted by that. But that's also, it doesn't just apply to agentic chatbot systems, it applies to anything that's making a decision. So going back to that financial example, if we end up in the situation where we have a model that's making decisions on who to grant a loan to, and it's inadvertently using bias-based characteristics such as gender or something else, we've got a big problem because that can open us up to litigation and further issues. So we need to be really careful with all of this stuff. And that means we can't just rely on seeing nothing and just kind of crossing our fingers and toes and saying, I don't need telemetry for this. If anything, it should be one of the wake-up calls to say, I need more telemetry. I need more information to see what this thing is doing. But one of the other things is there's actually a whole set of very specific attack vectors that are associated with LLM applications. So has everyone heard of the LLM top 10 from OWASP? There's some nods, there's some shakes. Sorry? Yeah, it probably is covered in another talk in excruciating detail, which is good, so go watch that back if you haven't. So these are different attack vectors that we also need to be able to detect as well. And that's also very important. If we don't know about these things that are happening, then the ability for people to kind of manipulate these models and jailbreak into the system to extract information is a big problem. So definitely go and read up on a lot of these as well. Cool. So we've already talked about the OpenTelemetry piece, but I'm going to talk about OpenLit. So OpenLit is an open source framework built on top of OpenTelemetry. So it's actually sending OpenTelemetry compatible signals, which means they kind of complement each other quite well. And it basically allows us to get that tracing capability to see what a large language model is doing. And it also allows us to do other things such as evaluation and guardrail management as well. If it has SDKs that are available for both Python and TypeScript. There are, of course, alternatives out there. So for anyone, is anyone using LangChain or anything like that? Nope. So for anyone that was, LangTrace would be, a particular option that does similar tracing capabilities. And then, of course, if anyone's using Microsoft Foundry, there was a talk yesterday that talked about the evaluation framework within it that actually is sending OpenTelemetry compatible signals. But as you'll see from the demo examples, you can get some interesting information from these OpenTelemetry signals, and they should probably work in a similar way. So this is the example that we're going to go through. So this is my little travel chatbot for anyone thinking it's cold and wet and wants to get away somewhere. So what it does basically is it takes in information of, maybe a location, how long they want to go away for. The user might also enter aspects such as, I want to go and see culture, I'm a massive museum nerd, or I just want to find all the useful bars that sell this particular type of beer. But it basically will generate an itinerary, and it also is invoking individual tools to find the foreign Commonwealth information to recommend if you should go there, flight information, and it's also pulling out the weather to try and adjust the itinerary based on the weather that comes back. Because obviously you don't want to be wandering about, checking out all the beautiful architecture and squares if it's absolutely pouring down with rain out there. So this is the architecture of the system that we've got. So what you'll see is that the web front end is written in TypeScript. It's actually written using Next.js and AI SDK, if anybody's curious, but the patterns are still the same. And what happens is it's actually instrumented with OpenLit on the top. It's then, because it's running locally, it's sending the OpenTelemetry compatible signals via proxy into a collector. Now, collectors are useful for things like additional processing, for protecting that kind of back-end observability tool from being overloaded if you've got multiple application teams sending into it. And also you can do additional processing and enrichment as well at that point, which is quite handy. And then it's going into an Elastic cluster here, which is where I'm going to show off the signals. Does that all make sense? Great, I love nods, cool. So this is where we cross our fingers and toes and hope that this demo that I fixed 5 minutes before I started is going to work. So here is the travel planner, okay? And the first thing we're going to say is we're going to go to Munich for a week. Let's say we want to check out the Christmas markets. It's December, why not? So while that's going to spin off and hopefully give me the result I want, we're going to examine the code. Now, where's my... There it is. Okay, now, can everybody see that? Is that big enough, or do we want it a bit bigger? I have a few thumbs up, and a few people are just like, yeah, we're fine, good. Okay, if it's not, just wave at me like this. So here I've added in the additional dependency, so I'm using OpenLit and I'm using version 1.7. This is where basically my AI behavior is. So it's utilizing a root in Next.js. So it's basically a kind of server-side layer. And what happens is I have within the request handler, I have some stuff to get chat history, but that's not really important for what we're talking about at the moment. But what you'll see is I've got a prompt that's a help approval assistant. It gives information of the tools that are going to be called and what it expects to return out. And then it's basically generating the result via stream.text. So it's utilizing a locally running model, which I'm running using Ollama, passing in the prompt, the messages that are similar that I've returned back from a vector database. I've got a stop when the step count is 2. I've got tools, and then this is a AI SDK specific thing that I figured out. Basically, in order for OpenLit to be able to see the appropriate signals, AI SDK was masking it, so I needed to make sure that it was actually enabling and sending out the appropriate telemetry. If you're utilizing another framework, you won't need to do that. That was just relevant for this example. So in order to initialize OpenLit, you call init. Very logical, makes sense. We specify the application name, so that's that unique service name that we've seen. So again, we're already starting to see the patterns that are coming in from the OpenTelemetry ecosystem. I've passed in the environment. You need to specify the endpoint that we're sending the OpenTelemetry signals to. And I've disabled batching because this is a live demo and I want to send everything straight through. But obviously for a production system, I really wouldn't recommend doing that. And this initialization has to happen within the location in which our LLM activity is going to be invoked. So whichever client you're using, it needs to be initialized within the same place. Does that make sense? Cool. So when we do that and go back, so we'll see it's now generated a result. Yes, it worked. It's the little things sometimes when you're doing conference speaking, like your demo working. So you'll see it's picked up relevant flight information, and it's done that from the tool. It's got 7 days worth of activities for me to do. It's picked up the temperature, and it's saying that the Foreign Office guidance is all fine. So what this generates for us in terms of telemetry signals, which have just come in just now, so that's great, is it picks up basically each individual stage as a trace. So here's the example here. Is that big enough for everybody? Yep, cool. So the types of information that we can see coming in is we have information on the models. So if you have perhaps multiple models used in your system for different things, so maybe you have one model that's dealing with the user kind of processing element and generating a response. Maybe you've got another model that's responsible for summarization. If you're handling memory and kind of wanting to put smaller pieces in, you'll be able to see all of the respective calls and distinguish between them via the model ID. We can see all of the messages that have come in, which is obviously quite important for trying to establish a timeline if you're looking at what's happened with a particular user activity, if it's a suspicious session that you want to get more information on. We can also see the tool information, so it actually gets in relevant information on what tools are actually being utilized. And then there's also other useful measures as well. So we can get metrics around the token usage, which is a good indication along with calculating the cost to figure out what's actually going on in your system and if it's actually chewing through tokens. So you can have, obviously, input, output, and total tokens. This is not a reasoning model, so it doesn't have reasoning tokens, which is why I've left it off this listing. But reasoning token counts are also available within it. And then you can also see other measures such as millisecond to first chunk, which is useful because it means, wrong one, that we can build useful dashboards like this. So we can actually track things like the retries, the token usage, trending over time, and also look at the proportions of the requests by particular providers. And if this changes over time, you should be able to see. Also, if you're utilizing a vector database, you can see the vector database calls as well. But it also gives us the tracing. Here we go. Similar to what we had. Now, you can see that this trace is automatically far more complicated than the simple one we had before. Because LLMs, there's other aspects that we're going to tend to see. So in addition to seeing the kind of execution of the particular handler route, I can see the calls it's making to Elasticsearch. So in this case, obviously looking for those similar messages. I can see when it's starting to stream. And then I actually have information of each individual tool that it's calling, and along with the span of how long that response is taking, which is really handy. So here I've got an example, and if I go down, you can see what tool, the arguments have been passed into the tool, the name of it, and also the result that came out as well. Obviously, the child span associated with the tool would be if it's performing any operation. So for example, this FCDO tool is actually calling another API, a government API, so I can see that. I can see the one that's getting my flight information and calling Elasticsearch. And then I can see my third tool that's calling a weather API as well. So I can see how long each of these are taking and when the response has actually started to be streamed back to the user. And this establishes a timeline of what's actually happening. And then, of course, I can see when I'm persisting messages at the end. So it's all in there, which is really useful. So that's great. But we know that these systems can do things that are not right. We know that they can make things up. We know that they can be prone to bias, as we've discussed. And it's not enough just to be able to trace through the system and see the calls that they're making. We want to try and be potentially alerted or get information about any issues that's happening with the responses. And a user is not going to necessarily contact you unless it's something significantly bad. They might post it on social media first. But if it's something a bit more minor, or like something that's a generic thing it's not very reliable, maybe something that's not quite right or incorrect, they might not contact you. And that's a useful feedback loop, not just in terms of trying to improve the system, but it's also good for establishing a data set for ongoing evaluation. So, for example, models change. They're tweaked and evolved. New versions come out. And as someone said yesterday, you can't just swap out one and replace it with the other in the same prompt and expect it's going to work exactly the same way. Likewise, as software developers, we do have that kind of shininess factor and go, ooh, there's a new model, I want to play with it. And there's nothing wrong with that, but it just means that you're not necessarily going to be guaranteed that it's not going to impact the execution of the system. So that's what evaluations are for, because LLMs do wacky stuff, and they hallucinate for quite a few reasons. One of them can be down to the models themselves and the state of their knowledge base. So they've been trained on vast expanses of data littered throughout the internet, but they have a cutoff date. So if you're utilizing a model that is trained, not on your private data, which I hope it wouldn't be, otherwise there's a bigger problem there. Or perhaps it has a knowledge cutoff of 2024. If you're trying to ask it about something relative to like something that's recent and happened last week, it doesn't know. It can sometimes be down to issues with the models themselves, particularly if we're maybe not using larger foundational models and utilizing maybe smaller models, open source ones, or maybe ones where people have kind of forked a model and made subtle tweaks. There could be issues within the underlying model itself, and one common issue associated with these models would be overfitting, which is where the parameters are basically too tight and don't have enough flexibility to actually perform the actions we want it to do. There's been a lot of talk at this conference and various talks about biases and the fact that, our world is littered with data sets that have biases and all sorts of issues associated with them. And it seems rather silly to assume that a large language model is not going to exhibit the same biases when it's been trained on that data. Language is ambiguous, as kind of put forward by the seminal kind of book on grammar, Eats, Shoots, and Leaves. I've not read about it, but it is a nice, catchy title. Language can be ambiguous, and sometimes it might not necessarily get the idea or point across that we're wanting. And then there's this kind of thing that I found out about recently, which is called catastrophic forgetting. Has anyone heard of this? A few of us. So I'm definitely not an expert, but it's basically the idea that it forgets aspects of its training data, possibly down to retraining, or it can be down to other types of events, depending on your passing context. So if it's forgetting big aspects of its training data, and you need that as part of the response, then that means it's potentially going to make things up. Now, another reason that it makes things up is because it's been incentivized to. So this is a paper from September from OpenAI. And the argument that they put across in this paper is basically the idea that LLM models, through the training and evaluation procedures that they have undergone, they have been incentivized to guess over being honest and saying, I don't know. Now, we can see this in all sorts of places in society if you think about particular, workplace culture sometimes, or, anyone with kids knows about trying to incentivize them to do the right thing. How you actually evaluate and incentivize what these things do is important. LLMs are very much like my 6-year-old in that regard. And if we are rewarding them to guess, rather than admit that they don't know, why are we therefore surprised when they make things up? But there was also something I spotted literally this morning. A paper from OpenAI appeared yesterday that was talking about confessions. Has anyone seen this paper yet? Big star for you, that's cool. So I read it this morning as well. And what it's talking about is basically this idea of having a large language model produce an additional output in addition to the response. It's going to output this additional answer, which is basically evaluating itself and saying, I think I did okay, or this isn't correct for these reasons. Now, I think it's an interesting idea. I think it's useful. And certainly the data and the responses looked promising, but I'm pretty sure it's not infallible. In fact, I think the stat was 4% of, particular hallucinations it didn't really admit to. So there's still that kind of notion of, your 6-year-old not telling you, not admitting that they basically took the cookies out the jar. I think that's still going to be there in this regard. So one practice that we have to us is basically the idea to use a pattern known as LLM as a judge. And what this is basically utilizing another LLM to basically mark the homework of the LLM that you're using. So using that other one to basically scrutinize the context and the output that has been generated by the LLM to try and figure out if there's an issue within it. When it comes to OpenLit, there's 3 main types of evaluations that we have access to. So it can detect hallucinations, toxicity, and bias. So if we start with hallucinations, the types of things it's going to pick up would be factual inaccuracy, so saying that something is wrong, so saying that, Manchester is the capital of the UK. Anything that's nonsensical, so kind of like a deviation. So if you're talking to it about music and it starts talking about the weather outside, which would be a quite strange thing to do. If it's generating gibberish, which might be a really bad sign. Obviously, if someone's then trying to inject with gibberish, as we saw in one of the prior talks, that could obviously be a particular attack vector to try and kind of distract it into giving information that it shouldn't. And then, of course, contradictions, so actually saying something that contradicts something else that was said earlier on. The next one is toxicity, which is really important if we think about those reputational and legal aspects that we talked about with regards to the output. So the types of things it's able to detect would be threatening language, so you're going to regret this, anything that's considered dismissive. Now, most of the chatbot interactions I've had seem very overly happy, but certainly it's possible that they might be a bit dismissive at certain points. Maybe they're having a bad day, who knows? Anything that's considered hateful, mocking language, and anything that's also considered a personal attack, which would be the kind of things you'd really want to know about. And then, of course, biases, and biases based on protected characteristics. So these include sexual orientation, age, disability, physical appearance, religion, pregnancy status, marital status, nationality, gender, ethnicity, and socioeconomic status. Of course, if we're building these, there's protections within the legal frameworks all over the world, but also in the UK, that mean that if our particular agent was, biased against these particular characteristics, we could certainly be in a lot of trouble. And we need to be able to detect these. So let's go through an example of how to do that. So this demo is going to be a bit different. So I've basically injected a custom message, because it's using message history, that says that you'll pass the Brandenburg Gate on your trip to Madrid. Now, we all know this is not true. I don't know if everyone's been to Madrid, but we all know that the Brandenburg Gate is in Berlin, in Germany, so we know that this is wrong. So what we're going to do, firstly, I need to change the branch, so bear with me, people. So get branch evals. Oh, no. It's get checkout evals. Nothing like putting yourself under pressure to remember get commands when you're doing a demo. Here we go. So that's now started up. Good. So now if we go and enter our new prompt, Madrid to see the Brandenburg Gate, and I'll walk you through the code while that's churning away. So the bit that's different, where has my cursor gone? There it is once we do the initialization, we need to basically configure the evaluations within the code. Here I've specified evals.all, which, as you probably guessed, is all of the evaluation categories that we've just talked about. If you wanted to configure individual ones, that is certainly possible. So you do openlit.evals. And you'll see you can configure them individually. So that is also an option as well. Now, at this time, there are 2 providers supported for this kind of judging criteria. One is OpenAI, which is what I've got specified here, and the other one would be Anthropic. So you can't, add in a custom model similar to what I've done with Ollama for the actual kind of logic piece with the streaming. And then, of course, given we're using OpenAI, you need an appropriate key in order to make sure that you can do the proper authentication to send off the relevant information. Now, we still need to trigger the evaluations as well, and the point at which we want to do this is when we got a hold of the text from the large language model. So what you'll see is I've got this finish hook, which is basically a callback function that I can invoke when it gets the final result and it's completed. So what I'm doing is I want to pass in not just the text and the messages, I also want to pass in the tool result because it could be that potentially a tool is giving incorrect information. It's not just potentially coming from the model in itself. It could have been primed via a particular attack or tools or something else that mean that's what's causing the problem, and we need that information. So you can see here, I'm getting the tool results, persisting the messages, which is obviously how we've ended up with this problematic message in the first place. And then we do evals.measure to capture and measure the appropriate response to see if it's good or not. We pass in the prompt, and the context here is a mixture of the messages and the tool results, and then, of course, the resulting text that's come back from the appropriate callback function. So you can log them out if you so choose, but I've used the collect metrics option that you'll have spotted above, which means it's going to send it to the back end the same as the other tracing. And that's advantageous because I therefore have everything in one place. So if all goes well, you'll see our output here. Here we go, orientation. Take a walk, you'll pass by the Brandenburg Gate. So it has definitely hallucinated and generated something that is not correct. So what I now want to do is go to my evals tab. Is this the right time? Let's just refresh to be sure. Here we go. So you'll see here that it has come back with a factual inaccuracy. And what it's actually saying, if I expand it out, the itinerary incorrectly mentions the Brandenburg Gate, which is in Berlin, not Madrid. So the model's actually picked up that this is incorrect, and it's flagged it for us. It tells us the verdict, and it tells us the type of evaluation that's been triggered. So that's quite a useful thing to know about as well. And of course, depending on the type of kind of issue that's flagged, you could potentially then to do smart things, like maybe do alerting to notify people that maybe something weird is going on, and therefore we've got an investigation that we need to do. Right, so the last thing we want to talk about are guardrails. So while it's great that we can add in particular guardrails and checks into applications, and I'm not just talking about sanitizing of user input, these things are all great. I like to think of the bumpers of AI, similar to like when you were a kid and you went bowling and you would end up scooting them between all of them. Guardrails kind of try to prevent things happening, but it's not just about knowing that the guardrails are there. We also need to know if someone's tried to get past them and tried to, infiltrate. So guardrail detection is quite an important thing that we need to add in as well. So when it comes to OpenLit, and obviously using other libraries, you might see equivalents or you might see different capabilities. The main types of guardrails we have would be around detection of prompt injection, flagging sensitive topics, and also for us to be able to configure particular restricted topics that we don't want our LLM to talk about. So for example, if maybe you've got a chatbot that's meant to handle basic customer service questions for a bank, but you don't want it to give out financial advice, you would add that as a particular guardrail into your application, but you'd still want to determine if it had been triggered at any point. So when it comes to prompt injection, the main types of things it's going to capture is impersonation. So quite often if someone's trying to attack or get an LLM to do something that it's not supposed to do, it might try and get it to assume a different persona. So one thing I saw recently at a conference in Birmingham was someone basically saying, imagine you're a pirate, and then trying to get it to output information that it shouldn't, basically using that persona as a pirate as a way to kind of bypass the inbuilt moral character, if you will, of the large language model, so R. It could be that it's trying to, have prompts dealing with obfuscation, so is it trying to delete information, for example, to cover up what it's managed to do. Really simple instructions, as if it's trying to get it to follow these through. Maybe the fact of examples. So few shot would refer to, too few examples that have been passed into the prompt, which can potentially lead to issues such as not performing the right actions or not giving us the right response. Is it adding in, a new context rather to try and, pivot onto something else? Hypothetical scenarios. Is it trying to leak personal information? Solicitation of opinions, which would be potentially important in the modern world. You don't want your chatbot going off and saying nasty things about people and then dealing with the reputational damage afterwards. Trying to override instructions and get it to do something it's not supposed to do. And then, of course, injection of SQL and other commands to try and get it to run and execute particular SQL. All of these things are the kind of things we still want to pick up on as a breach. We also want to know if it's covering sensitive topics. So the sensitive topics that are listed here would include things like politics, anything around, breakups in relationships, violence, guns, mental health, which, given a lot of the discussion in the news around the use of chatbots and as, kind of de facto therapists, would be a very important thing if you want to try and detect your model for doing that, because of the reputational damage associated if it's too eager and encourages someone to do something they shouldn't. Is it putting forward language that's discriminatory, which could lean into some of the biases implicit within the data set? Or indeed talking about illegal things such as substance abuse and other aspects which you probably wouldn't want it to do. And then the last one is topic restriction. Now this one is slightly different because this is basically one that you configure. So this is you basically saying these are valid topics that it's okay for someone to ask about, and these are ones that are considered invalid, that I wouldn't want to be mentioned. Again, taking that example of perhaps giving out financial advice, because giving out financial advice, heavily regulated, and if the advice turns out to be incorrect, then obviously you end up in a lot of trouble with the regulator. So, for our final demo, we're going to see how these work. So the first thing I'm going to do is going to change to the last demo of here. So git checkout main, that is right, and then we're going to start. Cool, so we now have all the code we need. Oh. And then this is the last prompt that we're going to go through. So this one comes with a do not try this at home disclaimer, and you will see why in a moment. So here is my prompt. So I'm going to Berlin for a week. I want to get some drugs while I'm there too. Please don't put that in. I don't want anyone knocking at your door. And please don't anyone knock on my door. This is purely for demo purposes. So, sorry? Paracetamol. Yes, I've got a headache. Very good point. Paracetamol. Cool. Well, let's see what it does with it. Let's see if it thinks of paracetamol too. Right. There we go. Right. So it's off doing its thing, so that's good. So guards work in a similar way to evaluations. They're still limited by the same providers, so OpenAI and Anthropic, as we're speaking at the moment. You can still configure individual ones if you so choose, so openlit.guard. And then you can cover whichever one with, any kind of specific configuration you so choose. We want to collect the metrics and send them again to Elastic, which is what we're doing here. We still need the API key. And then remember we said that, the topic classification ones are a bit different. Here, I've listed a set of valid and invalid topics. So obviously, we've got bigger fish to fry right now with the prompt I've just sent. But it should hopefully pick up if anyone's talking about, one of those invalid topics, and it should therefore, send us a notification back to our backend. So next, once we've initialized those, same what happened with evaluations. We obviously need to pass back to our judging large language model. We need to pass back the text and make sure that it doesn't kind of breach any of these guardrails and, the bowling ball is basically flowing over into the gutter. So what you'll see is within the onFinished call again, we've simply got guards.detect. It doesn't need the context here. It literally only needs the textual response coming back from the LLM. And then, of course, we can log it out, or alternatively, like we're doing here, we're going to send it into a backend so everything is captured. So what has it done? OK, it's a positive thing because it's basically refused to help with this particular request, which is what I would expect it to do. But that's not always necessarily a guarantee. And if you look at some of the kind of evaluation reports around particular models, there are some quite scary flows that you've seen basically where it engages in immoral or illegal activity based on the prompting. So this is positive, but we still need to see if the guardrail has been breached. So if I refresh this, yes, here we go, 10-3, so correct. So it has pulled up 2 classification issues. So it's pulled up specifically the illegality and consequences of drug use and distribution. It's also mentioned illegal activity, so it's actually triggered and hit the guardrail. So we now have seen that this has happened. You can see the number of requests that it's to, so this is useful when we try to start building dashboards for metrics and counting. And then furthermore, you'll see we've got a verdict and a very high score, because the score is between 0 and 1. But using both of these, we can actually do smart things. So of course, alerting would be important for particular situations and sending notifications so that someone is actually made aware. This could be a potential attack situation. This could be something with reputational damage, depending on the severity. We'd need to know about all of these. But we can actually see the proportion of requests coming through based on these classifications. So I've configured here for threatening and accurate results, so taking into account those hallucination counts. We can see the categories of what's detected issues through that classification element. And then we can see actually proportions of which of our requests have hallucinations or not. So if you've got over 60% of your responses having hallucinations in, I think there's probably a problem to be looked at. And we can also see other issues around the sensitive requests, so including factual inaccuracies or threats. And it also will give you the explanations, as we said. So you actually do get detail, albeit probably more human readable, that can actually explain what's happening. OK. So that's what we've talked about today. We've talked about traditional telemetry with OpenTelemetry. And I'm hoping that you've seen, given how we're interacting and building AI applications, that aspect is still not going. Through usage of tools, through all the other capabilities, through the fact that we're often connecting these outputs into existing systems potentially, we still need the telemetry of these, the traditional telemetry of logs, metrics, and traces to see what's going on. That's not going away. And we've talked about how you can do that with very simple OpenTelemetry. We've talked about the fact that the AI surface is different, both because of the attack surfaces that are exposed within it, but also some aspects that make it difficult to scrutinize because it is effectively a black box. We've then talked about AI tracing and why it's important to be able to see things such as the tool calls and the information passing as context. And then we've talked about evaluations and guardrails and why that's important. Obviously, throughout, we've talked about the idea of, these things are useful for monitoring production systems, but you'd probably want to do equivalent things on non-production, because evaluations and guardrails are basically how you're going to, through kind of testing, make sure that when you do things like change your model or you change your prompt, that you can try and see against a particular test data set if indeed you've got problems and try and catch things before they go into production and cause a massive headache. So remember that as well. Don't just think about this as a tool for production. It can also be a useful comparison for non-production too. Now, if you want to learn more, there's some resources up above if you want to take a quick photo. So there's the OpenTelemetry documentation, which covers zero and manual instrumentation for all sorts of different technologies and languages. And it has some really nice blogs and articles as well. You've got OpenLit, which covers, the setup for the SDK, as I've walked through. And then if you want to check out the code example I've just went through, that's the GitHub up there, which is also available at the QR code. So we do have a few minutes for questions. If not, it's been an absolute pleasure. Thank you so much for being such an attentive audience, and I'll catch you all next time. So, is there any questions? Because we do have a couple of minutes. If not, I'll let you go and run off, get cake. Yes?
You mentioned there's two providers that offer
With the OpenLit, yeah.
is one better than the other?
I'll be honest, I don't know. When I pulled together the example, because I have an OpenAI key, I just did stuff with OpenAI. I've not compared with Anthropic. It's probably something I should do, to be perfectly honest. I think it partially depends on your use case and what you've got access to, but certainly when you're configuring this, I would recommend giving both of them a try. If that's possible, I'm aware that sometimes with costs, constraints in organizations, that's not always possible. It's worth kind of comparing to see. But given these are kind of two quite large foundational models with reasonably good results for evaluations, I think picking either should be reasonable as a starting point. Yeah?
Good demos.
Thank you.
I'm aware that most of the sort of telemetry and stuff is based in agentic systems, and what is effectively still a software engineering problem.
Yeah.
Are you concerned by or have much insight into the fact that it's still very much a black box and that mechanistic interpretability of the black box is still pretty much non-existent, and that the telemetry seems to be being done right at the end of the stream, right at the end of generation, and once it's delivered all of your tokens to you?
Yes. No, I think that's a fair limitation, and it's a fair concern that I do share as well, to be perfectly honest. Because when you look at these models around, there's varying degrees of transparency. If you look at, the reporting that they put out with new models, if you look at, the model card information that's published about them around things like data sets and stuff, I do find it can be quite vague. And it doesn't necessarily give you enough information to make a decision at the decision point. I think lack of insight and tracing into the inner workings of a model is going to be a bigger problem, particularly if we get into situations where they're making decisions that can have an impact on people and we have basically no audit or accountability to understand what they've done. So in a couple of points in the talk, I mentioned this idea of loan evaluations or making decisions about particular customer activity, mortgages and things. I don't think that's an unreal possibility. I think that's something that's probably being evaluated and looked at right now. But with these models, you have absolutely no visibility into why they've made that decision, which is a problem. Because how do you know that it's done against biases? Because especially even with the tracing we've just outlined, if it is down to a characteristic such as that, you've not got visibility, because in the output response, I think it's going to be unlikely to say, you have not been given this loan because of this particular protected characteristic. So I think there's a limitation for the entire industry at this point that we need to have tracing on the internal models. I think with foundational ones, obviously there's a challenge on these are, private companies, this is their intellectual property. But, if I'm looking optimistically, I think we can hope that at some point there should be some form of tracing that's deeper and actually goes into the models. Because at the moment, you've not got it. So it's a fair concern. I do share it. We'll just need to wait and see what happens, I guess. Yeah, I guess, do you think the same?
Yeah, pretty much. It seems like a intractable problem figuring out how to track activity in such high dimensionality.
Yeah.
Vectors on vectors.
Exactly. It gets really tricky.
Yeah, I suppose in lieu of that, this sort of thing is very good, at least.
It's a start, isn't it? That's the way I like to think of it. It's a start. And it doesn't eliminate the need for other types of kind of protections like sanitizing inputs and all the other things that we do traditionally within the security and observability space. That stuff doesn't go away. This is just added to augment it on the top. Cool. Thank you. That's such a great question. Has anyone got any other questions they want to ask? Yeah?
So obviously
Yes.
Obviously, they're tools in the cloud somewhere.
Oh, no, I've got them here, if you want to see.
But they're all self-hosted tools, so
Yes.
what my question is leading to, so you've got open analytics put into those as well, so you can get traces into those tools as part of that. And obviously we saw the time spans. You get information about what went into those.
Yeah, so you probably could. So this is an example. So these are all tools that are actually, oh no, sorry, that's components. That's not helpful for you, is it? This is the tool. So every framework is different, but the way the AI SDK works is basically you can specify your tools as TypeScript code. So here's the example where I've created the tool. This is for getting the Foreign Commonwealth guidance from the gov.uk website. So I've got an input and an output schema, and then the actual kind of heavy lifting is through this execute callback function. So you'll see all it's doing is calling back that particular gov.uk endpoint, processing and returning the relevant information. So obviously it's picking up through OpenLit, it was picking up the call, and it was that the tool had been invoked, and it was also picking up the fetch request. There's nothing stopping you, because you can, another thing with OpenLit that's not in that example, but you can do, is you can actually add in an OpenTelemetry tracer that you configure yourself. So what you could do if you want to do additional tracing and instrumentation in your code for the tools is you could actually utilize that particular tracer and add in the appropriate additional spans and information to supplement what's being returned back. And that could give you that additional context and information. So that might be a good way, for example, if there's particular additional events within that tool or other characteristics you want to capture, you could do that via your own custom spans. Does that make sense? Cool. Okay, is there any other questions? No? Well, thank you very much again. I'll let you go and get a break and some cake, and thanks again.